Good evening, and welcome to Sense of Place. We have a fantastic show for you tonight. My name is Sarah Fox, and I'm very excited for you to join us for Mostly Mushrooms with Krista Cushman.
Excuse me? What do you think you're doing?
Hi, Mom, and I'm introducing tonight's show.
No. That's my job. I come out here, and I look at everyone, and I say, welcome to Sense of Place, and I say, my name is Sarah Fox.
I already did that.
But there's other stuff. I do all that, and then I say, and I want to make sure that we recognize our sponsors, because without them, this doesn't happen, and these are people in our community who help make that circle go round, and I hope that we all can support those who support us, because that's how it happens. And then I remind people that Sense of Place is a program of Mount Adams Institute, which is a local nonprofit doing amazing work here in the Gorge with Sense of Place, but also all across the country. And then we get to introduce the speaker.
But tonight, I'm going to be introducing the speaker.
And why do you think you should introduce tonight's speaker?
Because she's my teacher, and she's been teaching me for 2 years, in 4th and 5th.
That's a pretty good reason. But tonight, Krista is not here to be a teacher of 4th and 5th grade. Tonight, Krista is here to talk about mushrooms. And what do you know about mushrooms?
I know a lot about mushrooms. She teaches about mushrooms and the outdoors. Like, did you know that mushrooms are more closely related to humans than plants?
Is that true? So if I see a mushroom, it's more like me than it is like the plant right next to it? You know that. And you learned that from Krista? Should we let her do the introduction? Okay. Go for it. You can do the introduction. Hey, nice outfit, by the way.
Krista Cushman has spent over a decade exploring and sharing the world of mushrooms and fungi through community, science, and education. She has earned her master's degree from Lewis and Clark College and teaches 5th grade in Hood River, where she lives with her husband, their daughters Benny and Edie, and their dog Sal. Krista weaves her passion for fungi into her teaching, guiding community education, and hours spent wandering the forest between Mount Adams and Mount Hood in her home, the Columbia River Gorge. So please help me welcome Krista Cushman.
Thank you so much, Tate. Thank you so much. Oh my gosh. Welcome. Tonight, I want to invite you all to see the world and our home through the lens of mushrooms. And perhaps tonight and in subsequent years, you'll find what I have, that turning your attention to the tiny details of the fungal world will give birth to something much bigger, a relationship and a realization of the personhood of the natural world. So with that, let's turn our attention to what makes our home so special. Okay, so what does make our region so special? Well, from this map shows us that the West Coast has a near monopoly on elevation. And this, from a fungal perspective, is related to temperature. And for mushroom hunters, this means time travel. This means that morels start to fruit near the Columbia River in the cottonwoods in the early spring, and we can follow them up, all the way up the mountain, all the way until August. And the same thing happens in reverse in the fall, where we start in the high mountains by the alpine lakes, and we can come down until now we're hunting chanterelles close to the river. This means we live in a mushroom paradise, a unique place in the entire world. And also, this special place houses a special type of mushroom that requires melting snow, snowmelt mushrooms. This snowpack fungi is unique to the western United States and is specific to habitats at the edge of melting snowbanks. It's currently listed as near threatened due to significant decreases in snowpack due to climate change. I found this one at Paradise Park on Mount Hood last summer while on a run. And among the wildflowers and a big patch of melting snow, the forest floor was carpeted with them. I was stopped in my tracks. And this one actually popped up from the snow. Its little metabolism heated it up and melted the snow while it was growing. This is one of the many snowbank mushrooms that only grow in this specific habitat, using water to propel its growth. So from the perspective of mushrooms, our elevation brings us time travel, temperature changes, and unique habitats, which result in really unique and special mushrooms. Another one of the factors that make our home so unique is that it falls at the cusp of two distinct habitats, one wetter and one drier. It works like a gradient that gives us access to remarkably different habitats within a really small area. These habitats greatly increase our species diversity. Like, for example, some mushrooms are specific and will only grow in a certain type of downed wood or a certain kind of tree, while others are generalists, like this Ganoderma, also known as the West Coast reishi. One of its primary host trees are hemlock, but it can grow with a host of trees that favor the wet western side of the Cascades. This species is related to another mushroom that also resides in Asia and Europe that for over 2,000 years has been known as the mushroom of immortality. And I've made many a tincture and tea out of it. Tastes a little soily, but I'm sure it's doing me some good. I also want to shout out, you'll notice this little bird icon in the corner, and I just want to shout out iNaturalist. I gathered this data from people like us that logged every single time they found a Ganoderma or a hemlock. And so this is public data. This is community science data. So another generalist is the spring king, or the Boletus rex verus. But unlike the Ganoderma, it prefers the firs and pines of the drier eastern side of the Cascades. This photo was taken on my birthday, where we found a honey hole of spring kings. I chopped them up, put them on the hood of my car, backcountry skied up and down Mount Adams, and when I came back, they were perfectly dehydrated. Really the birthday present of my dreams. So I want to reiterate that where we live is so fantastic for mushrooms because we have the ability to access both of these diverse habitats. Okay, so to recap, our home is unique because of access to elevation and precipitation gradients. But now I want to move away from these generalist mushrooms and talk some more about specialists. And to do that, I need to introduce the larch tree, a deciduous conifer, a weirdo that defies categories, much like mushrooms themselves. Without the larch, a wide range of specialist mushrooms disappear. Mushrooms like these hygroscipes, this beautiful little orange thing in the corner, a waxy cap, or this psoilus, this pored thing. The larch connects the Asian continent with ours, and it also traveled through the boreal forest that connects the Pacific Northwest with the far northeast. This is why Maine and Oregon share some of the same mushrooms, despite mountains and thousands of miles separating us. We also have a lot in common with Asian fungi, but once again, where we live is special and unique because it's a confluence of all of it. A rainfall gradient, access to elevation, and the larch. Okay, so we live in the most magical place on earth for mushrooms. How do we engage with mushrooms in this really special place? Now what? Well, let's start where we are. Most of us come from three kind of spheres, three pathways into this room. One is mycophobia, and I grew up this way. Bless my mother's heart, who's here, but if I saw a mushroom, she'd slap my hand away. Maybe not slap, but she would definitely tell me that that's toxic, it could kill you, do not touch that thing. Many of us grew up this way. Also, I think increasingly it's more popular that family members have taught you how to forage. Maybe you were lucky enough that your grandmother taught you how to forage for boletes. Or increasingly, there's public organizations like the Oregon Mycological Society that are teaching people how to forage for a specific type of mushroom. And also psilocybes. At every mushroom show, there's always a group of people that are in there because they're really driven and enraptured by the healing properties that are coming out. But I'm gonna kind of get away from all three of those. And to do that, and really to acknowledge all of this, we come with a lot of misinformation. So much misinformation. And so I wanna just kind of deal with that at the top. I normally save this until the end, but it just feels like I wanna get this out of the way. I wanna move on from this. One is that you can't touch any mushrooms, or if there's a toxic mushroom, if you touch it, it'll hurt you. But that's false. You have to both ingest and digest a mushroom for it to cause you harm. There's one specific mushroom in Southeast Asia that can cause a rash, but that's not here, so you're welcome to touch literally any mushroom you see, even the deadly poisonous ones. Another kind of misconception I hear a lot is if it bruises blue, it'll make you hallucinate, or maybe it'll kill you if you try to eat it, but no, that's not true either. Could be oxidation, could be something else. I also hear if an animal eats a mushroom, it's okay for me to eat. And nope, that's not true. Don't do that. Don't do that. There's lots of mushrooms that they'll eat that you should not, so don't. And I love this question because I really think it's when people start to want to engage with the fungal world a little bit more deeply. And it's, how can I tell if a mushroom is edible? That's the way I want to interact. How do I tell? But just like a stem on a plant doesn't tell us if it's edible, or the color of the veins doesn't tell us that a plant is edible, there's no specific trait in mushrooms that tell us it's edible. So you have to, unfortunately, I'm sorry guys, you have to know what mushroom you're eating, and maybe the toxic lookalikes, and also how to render that mushroom edible. So for example, morels can kill you if you eat them raw, but the toxin is rendered inert through heat. So I eat them every spring. They're delicious. Eat all the morels, but cook them first. There's also certain mushrooms that if you eat them and drink alcohol, they could make you sick. Some have toxins that are water soluble. So you have to know, just like you know that you don't eat a ton of raw potatoes, or you eat the stem of a rhubarb, but you don't eat the leaves, mushrooms are the same, and that's nothing to be afraid of. We can hold them to the same standards as edibility as anything else. So, know your mushrooms before you eat it. And finally, cutting versus plucking. And this is the one that I've gotten yelled at the most in the forest by any number of people who think I was doing it wrong. And we won't go over the internet. But we're not going to answer this question yet. We don't have enough information. So to answer this question, whether you should cut a mushroom or pluck it, we're going to first answer the question, what is a fungus? And the fungal kingdom, it's a kingdom of life, just like animals or plants. And like Tate said so beautifully, nice work, Tate, it's more closely related to animals than it is to plants. So it's a heterotroph. Hetero means other, and troph means nutrition. It gets its nutrition in another way, unlike plants that make their own food. When we eat, we take food into our bodies and we digest it. Mushrooms do the opposite. They exude enzymes and then they absorb those nutrients. Extracellular digestion. This exude and absorb, exude and absorb. They also have, they're also differentiated by their structure. Tons of undifferentiated tissue, no complicated organs, they have fewer cell types. Also their reproduction, spores, and I'm excited to dive into spores later. Also their cell walls are made out of chitin. Just like the exoskeletons of arthropods, like insects and crustaceans, like little lobster claws, but for fungi, they provide structural support and protection. The plant kingdom uses cellulose, and animals don't have cell walls. So, this is how I'm choosing to teach what a fungus is. Imagine that spores are flying through the air and they land. All of a sudden, cylindrical tubes of chitin, hyphae built by being strung together, start creeping and crawling. It's brilliant because the surface area to volume ratio, there's more surface contact on the outside of the cells than inside, so they can absorb and exude more efficiently. And these long hyphal strands, like threads that span out and twist and turn. Like if you've ever looked under a log, those fluffy bits, That's mycelium, the collective branch network of hyphae. It's the tree of the fungus. It's year-round, just like trees are. It's breathing, it's growing, it's eating. This is the true body of the fungus, the mycelium, and how the fungus spends most of its life cycle. And sometimes some mycelium won't even make fruiting bodies. A really popular example of this is the noble polypore. It fruited a few times, people went crazy, they're like, oh my gosh, look at this rare mushroom. But when they tested inside of trees, it was in nearly all firs. It just makes their fruiting bodies very, very rarely. So mycelium lives like this, like a tree does, doing its thing, until when conditions are just right, it weaves a tiny little water balloon, which swells into a mushroom. And what is a mushroom? A mushroom is a temporary, ephemeral, reproductive structure that's made by mycelium, the fungal organism. And it can last hours to months to years. It also informs the answer to our question, should you cut or should you pluck a mushroom? If the body of the fungus is the mycelium, then you can harvest the mushroom without destroying the organism. That said, the more time I spend in the forest, the less of an impulse I have to pick them and take them with me. I think most of the time, if you were walking behind me, you'd be surprised to know that I was there at all. This also informs us, if the body of the fungus is the mycelium, how to be good stewards of it. It means tuck in your mushroom holes. Don't trample the soil or bring large groups of people day after day to the same location. Don't use heavy equipment. Don't use rakes to harvest masutake. Care for the soil. So, I'm gonna say, as I've gone on this journey of getting to know mushrooms and our home forests, it might sound crazy, but I swear that I've had mushrooms call to me. Certain seasons, I didn't feel ready to identify a certain mushroom, but it came to me. The year that I identified masutakes, at some point, it was yelling at me so loudly it became rude to ignore it. And I believe that mushrooms are calling to you too, and all they want is your attention in return. So now that we have all these misconceptions out of the way, and you know that you can touch mushrooms, maybe a mushroom's called to you. So how are you gonna look at it? How will you pay it attention? This is tricky for me. I'm gonna be 100% honest, because this is every single slide that I've done so far is a 45-minute talk. Fungi is so deep, it's hard to know what to focus on. And these upcoming slides are no different. But knowing that we have our field guides, and knowing that sometimes people jump to identification too quickly and they forget to look, today I'm going to invite you to look. So the date and location is something you have to know if you want to identify your mushroom. And that is taken care of when you document them in iNaturalist, which we're all going to do now. So we're just gonna start with mycelium. Oftentimes on mushrooms, you won't notice any mycelium. But when you do notice it, it's an identifiable characteristic. Like in the top center here. On a hike at Lookout Mountain on Mount Hood in June, me and my family were next to a melting snowbank. And we saw this mushroom. And there's many mushrooms that look a little bit like this, but none that have this fuzzy, moldy looking foot at the bottom. That's a little bit of mycelium. And that told me what kind of mushroom this is, and that I could eat it. You see on the two outside pictures, just a little fuzzy white bit. That is mycelium. Not all mushrooms have it, but if yours does, that can help you identify it. They can also be branching or fanning, like in the Wallowas once we got to our campsite, and every single log was covered with this thick, branching, fanning mycelium. So when I had my field guide, it was really easy to identify it. It's gonna blow your mind, at least it blew mine, but mycelium can also be purple or orange. Usually it's white, but if it's not, that helps you. It can also bioluminesce. Yes, it can. It doesn't always, but if you have a mushroom with bioluminescent mycelium, that's going to help you identify it. Another thing to look at, so you got your mushroom, it called to you, you notice the mycelium that it had or did not have attached to the base and growing around it. And so the first thing you're going to look at is the cap. And it can be velvety and round, or it can be really slimy. It can be pointed like a gnome hat. It can have ridges and pits. It can be two-toned, flowery, or leathery. And some caps, you can peel away a slimy cuticle. This is a whole talk. It can be orange peel, textured. Look out for these guys. They're candy caps. What supports the cap is often a stipe. And that's just what we call the stem or the stalk-like feature supporting the cap of the mushroom. They can be bulbous or long. They can fall apart when you pick them up. If you've ever picked up a mushroom and you're like, ugh, it's all over me. Ugh, well, I can't look at that anymore. No, but I could tell you one of a few types of mushrooms that is. That's an identifiable characteristic. It's falling apart in your hand? That's good information. Also, there's some masutake up here. Squeeze it when you come up. No matter how hard you try, I bet you won't be able to break the stipe. The important part here, we talked a little bit about the basal mycelium, is to excavate the entire thing. Sometimes there's information at the very base. In fact, about 3 or 4 of the mushrooms that you see up here only looked like little brown mushrooms until I dug down into either the log or the soil. There can be little bits of tissue at the end, or there can be color changes. Some have a blue or a green foot. Good luck trying to identify an anocybe without that. So just make sure that you excavate the entire thing if you want to identify it. It's a whole talk we just went through. But another structure that some mushrooms have or do not have are veils. Particular types of mushrooms have veils. And here's an example of what a universal veil can look like. A universal veil is a strategy that some mushrooms use while they're growing to protect their tissue. And you see that the universal veil doesn't grow, but the mushroom does. So there can be little warts that you can scrape up. That's not part of the body of the fungus. That's remnants of a universal veil. It can also be kind of pancakey or scruffy. You can pick it up and it gets all over your hands. It can be slimy. Also, you see on the far right, there's a little bit of tissue at the base. That's called a vulva, and that's also evidence that there was once a universal veil enwrapping that entire mushroom. So much to talk about. I could just stay here forever. Another type of veil is a partial veil. And this is another example of a strategy that mushrooms use to protect themselves while they're growing. So the mushroom cap expands and the partial veil breaks. It can be skirted, it can be cobwebby, it can be velvety smooth, and it can be slimy, always slimy. So just notice, does my mushroom have a partial veil? If you come up here after, I would love it if you just started noticing, does this one have a partial veil? Does this one have slime on it? So there's a lot of things to look at up here as well. Okay, so we have the day and time logged. We've looked at the mycelium. We've gone over some of the structures. We've looked at the veils. Most identification guides, but not all, are set up by fertile surface or spore-bearing surface. So this is an important thing to know. Once you kind of like tune your eyes to notice what a spore-bearing surface is, you know what page to flip to in your field guide. So the one we are all most familiar with is gills. And gills are like pages in a book. It has a beginning and an end. You could remove one without destroying the whole body of a fungus. They're kind of like knife blades. And the things to notice about gills, once you notice you have gills, is everything. How do they attach to the stipe? Is there a little notch? Do they run down? Do they curve up? Are they kind of raggedy? I could go on forever, but I will just leave you with the thing that I always get most excited about. On some very small mushrooms, if you looked at the very edge of the gill, it can have a little color change. Okay. The next type of spore-bearing surface we'll talk about are false gills. They twist and fork and appear melted onto the flesh. They're blunt and thick and are more like speed bumps than blades of a knife. And they're harder to remove. These are like our beloved chanterelles. Another spore-bearing surface are pores. And they're kind of like toilet paper tubes that shoot spores out of them. And there's two kinds. One that's hard and woody that you would not want to chew, and one that's soft and squishy that would be chewable. And they're also removable. Here's an up-close picture of a spring king with those beautiful pores and like a crossways shot of what those tubes look like. Definitely poke the pores when you get up here. Worth your ticket price in general, just poking a pore. The cutest of all spore-bearing surfaces are teeth or spines, and that's a fact. Teeth hang down like, we all know. They hang down like icicles, like spines just underneath the cap, or sometimes like the lion's mane that you might be familiar with at the farmer's market. They're like a mass of spines. And I invite you the next time you find a toothed mushroom to pet it. So those are kind of the basics, but there are also things that don't fit into the categories because we're talking about mushrooms. They really come in all shapes, all sizes, all textures. And there's also a part in your field guide that has oddballs, so you can just safely put them there. But they can look like corals, like underwater, or these purple spines. They can be squishy and jelly-like. There's some really beautiful clubs up here for you to look at. And spores, we made it. The first time that I looked at spores under a microscope, I cried. They're so beautiful. They can be spiny or cylindrical. They're angular. There is a huge diversity in size and texture and shapes. They can go from 1 to 2 microns, like as small as a millionth of a meter, to something that you can see with your naked eye. And they all have to do with the dispersal strategy of spores. And so we already talked about the kingdom fungi, but I'm going to kind of move us down to phylum. And the kingdom fungi has a lot of phyla, but here's the thing. We only really interact with 2. And I want you to know them by the end of tonight. The one, like if we all closed our eyes and imagined a mushroom, like a fleshy thing with a cap and a stipe, that would be a basidiomycete. And if you looked in a microscope and cried, like me, you would find 4 antlers and 4 little spores on each antler, or 1 antler on each spore. The other phylum that I want to talk about is the ascomycete. And this is like a long tubular cell that has 8 spores per cell. 98% of lichens have an asco partner, which is so cool. But I don't think we notice these very often, but these are like morels or these beautiful helvellas, the cut fungi that really proliferate in the spring or after a fire. They could look like this funny black thing that looks kind of like a deflated plastic bag in the forest, but when you cut it open, it has this weird gel stuff inside. They can be purple, like violet crown cups, or this orange peel. So beautiful. And the funnest party trick is that you can blow in it. And there's my breath. And you see that I'm not blowing the spores out, but the little spore launchers get ready, and then they shoot it out. It'll make you really popular with your friends. This is a hard slide for me because I ruined it with circles because I realized nobody knew what I was talking about. But I'm going to ruin these with circles so you know what I'm talking about. So with your field guide, to identify most mushrooms, you're going to need to know the spore color. And there's 2 ways to discern spore color: a found spore print or making a spore print. And here are 3 examples of a found spore print. You see here that this is one that I found at Teacup with these golden brown spores. There was a cap on top of the other cap, and it dropped spores. So now we don't need to do a spore print. We know what spore color they have. Or these honey mushrooms in the center. The same thing happened. The top cap dropped it on the top of the other cap. We know that they're white. And here, actually, this is a little remnant of a partial veil. So we got like 2 bits of information here. It has a partial veil, and it has these rusty brown spores. So cool. If you look at your mushroom that has called to you and you do not see any spores on it, you can just chop off the stipe and leave it on a piece of paper for 6 hours to overnight, and then you can look at the spore color that way. And I'm hoping we can see this, but this is one of my favorite spore memories in the forest, not with a microscope. This is a morel sporulating in my car, and it was coming out of my basket in the morning light for 45 minutes. Isn't it beautiful, coming out in the wind? It's the little things, guys. And then, you're really here just to watch well, just wait till we get to the bird photos. And here's some Zalaria. And this is fruiting in mass right now, all over. Look, it's small, it's hard to see, but if you're really starting to pay attention, you'll notice it everywhere. It's so beautiful. Okay, so now every observable characteristic that we've talked about so far, it has to do with your eyes. Everything that you can see. But really, mushroom hunting is about using your senses. So it's time to move on to scent. You might not know this, but mushrooms can be fruity, like apricots or cherries. They can be sweet, like almonds, really dessert-like, or maple syrup. They can smell so chemically, like chlorine or bleach, or like vegetables, like really like radishes. 80% of mushrooms smell like mushrooms. So if you get a mushroom that smells interesting, that's an identifiable characteristic. You'll need to know that to identify the mushroom. And this is a whole talk, because once you start smelling mushrooms, you're gonna wanna smell everything. There's like, you want to compare it, you're like, oh, is this more broccoli or is this more like kale over here? Like, what's the smell happening? It's a little more shallot versus a little more onion. So I'm always adding to my scent repertoire, and just smell your mushrooms. You might get lucky. And when we're talking about using our senses, mushroom hunting is really about being in the right place at the right time. And if you find a mushroom that you want to find again, maybe your friend took you out chanterelle picking and you found your first one, you're gonna get a huge dopamine rush, and you're gonna wanna pick all of the mushrooms, and you're gonna get so excited, you're gonna leave, and you're gonna have learned nothing. So pause and start that conversation. Give a little bit of your attention. There's not any information that you can get that doesn't add to your knowledge about it. So I know how big the grand fir tips are when I'm gonna find porcini that are just right. I know what flowers are blooming, and I know my allergies are bad when I know that I'm gonna find morels. There's a little blue butterfly that I see, and whatever flower that it wants to go to is there when I want to find mushrooms in the spring. What are the plants doing? You don't have to know all their names yet. What is dying? What is living? What birds are singing? That picture in your brain that you get is called indicators. That's the mushroom in the cottonwoods, and then you can move it up the mountain throughout the year. It's the most deep part for me. The best part about mushroom hunting is the noticing and then finding those same patterns over time. We've made it here. So the mushroom is called to you. You've been able to engage with it a little bit, but what is it doing? This is a whole talk too, but I want to talk about 3 ecological roles. These are not the only roles, and they're really also very simplified. Mushrooms don't like to fit into categories. These are ours, and every mushroom kind of wobbles in between many of these. We're gonna start with kind of the ancestral trait of mushrooms, a parasitic, like the proto-mushroom. The first mushroom was a parasitic mushroom, and that means it has a relationship where they benefited at the expense of their living host, harming it in the process. And there's no more perfect example of that than the humongous fungus in the Malheur National Forest in the Blue Mountains of Oregon. It's estimated, depending on who you talk to be anywhere from 2,000 to 8,000 years old. And it's genetically the same over 3.5 miles. That means even if there's a mushroom there and a mushroom way over there, and 3 miles over there, there's another mushroom on another tree, the mycelium is all the same. The mycelium is all the same. And it's also a perfect example for me because it doesn't fit neatly into boxes. It behaves differently based on where it is regionally. So east of the Cascades, it's aggressive. It's been killing healthy trees over there in that forest for thousands of years. But if you go to the west side where we live, it really only shows up in sick and dying trees. Mushrooms, man. This slimy, adorable, slimy partial veiled, now we know this, and the little gold foot at the end, the little yellow foot. This little thing, people used to say, oh my gosh, it lives with trees in harmony. It's always hanging out with pines. What a lovely little thing. It loves those trees. No, it doesn't. It's actually a parasite on this mushroom that was living in harmony with trees. So it was getting sugar from trees, but via this other mushroom. So mushrooms can also be parasitic on other mushrooms. And probably the most classic example of this, and the most delicious, is the lobster mushroom. This white Russula brevipes over here, that I'm sorry I have to tell you, where the stipe and the gills meet, there's this little blue line on this one. Do you see it? Maybe it doesn't show. It's so pretty. Gosh, it's so pretty. Not all of them have that, but this one does. Anyways, this I found in one of my most favorite patches of old growth in the world, and they were right next to each other. So somehow, nobody really knows how, whether it parasitizes the mycelium or if it gets on those little water balloons that the mycelium weaves, but at some point, Hypomyces lactiflorum, or the lobster mushroom, attacks the Russula brevipes and turns it into the lobster. They're both edible. The common kind of story is that this is a mediocre edible and the lobster mushroom's a delicious edible. But I will say it's kind of going out of fashion and people are saying give the brevipes a chance. But I'll say, if you look here, there's no gills anymore. And if you looked at this under a microscope and started crying, you would notice that there's tiny little cups. This no longer has those basidiomycete spores. What? Amazing. And so you might be like, man, those parasitic mushrooms are so nasty. They're out here killing trees. I love trees. I'm for the trees. Don't kill the trees. But that's not what these young white-breasted nuthatches think. A dead tree can support a whole lot of life. And it's also an excuse for me to show photos of birds. Also ruin another picture with a circle because nobody saw the little mushroom that's up there that was probably responsible for making the wood soft enough for these pileated woodpeckers to make a little nest inside. So if you have a dead tree or part of a dead tree in your yard and it's safe to leave it, leave it. Leave it for these adorable little birdies. So at some ancient time in the past, there was parasitic mushrooms, and then saprotrophic mushrooms started to evolve. And sapro means decay, troph means nutrition, so it decomposes wood and other organic materials that are already dead. And this has propelled 90% of all decomposition on Earth, and it cycles nutrients so that plants can reabsorb them, so it fuels that next phase of forest growth. They're also used for mycoremediation, like breaking down agricultural and plastic materials. Oyster mushrooms have been found to do this. These are also the type of mushrooms that you find in your grocery store or at the farmer's market because they just need that dead stuff to eat and grow, like the cremones and the portobellos or the oyster mushrooms. So at some ancient time in the past, brown rot mushrooms started to evolve. And they consumed the hemicellulose and the cellulose. And what this does is it leaves tiny rectangles in logs. So if you've ever been in the forest and you've seen a log that's full of rectangles, that's a mushroom that ate that. That's a fungus that consumed the cellulose and left tiny little rectangles. I don't know if this is true, but I imagine that at some point in Earth's ancient past, it was all geometry and everything was rectangles. And then white rot mushrooms came in, and they consumed both hemicellulose and cellulose, but also the lignin. And if you've ever been in the forest and you stepped on a log that you thought was solid, and then it totally cracked, it just disintegrated, you can thank a white rot mushroom. And when white rot mushrooms evolved, they ended the first coal age. They're more aggressive, generally, than brown rot mushrooms. So if you see a shredded log, now you know what's going on. If you see these little rectangles in the forest, you know what's happening. Shaggy manes are the one I'm going to use. Shaggy manes are a delicious edible, and they behave differently in different types of soil. In low nitrogen soils, they excrete this enzyme that attracts, paralyzes, and then dissolves predatory nematodes, which are animals, and then they digest it, kind of like they're hunting. They don't do this, they behave in low nitrogen soils. So some mushrooms are hunters as well. Okay, so the coal age is over. Thank you, mushrooms. If only it was sooner. We're gonna get into mycorrhizal fungi. And this is a mutualistic relationship with the trees and the plants in the forest. This is the type of relationship where both organisms benefit. So the fungi will combine with the mycelium with the tree roots. Myco means fungi and rhiza means root. So the fungus gets sugar and carbon, and a tree gets a lot. Gets a nutrient boost, increased water absorption. In fact, fungi can supply up to 90% of a plant's phosphorus and nitrogen, while trees get an extremely expanded reach. So the fungal threads vastly increase the surface root area absorption. They protect them against pathogens, and they can even help plants tolerate drought and heavy metals. Mycorrhizal fungi form ancient, vital relationships with plants, and it's like a 450 million-year-old strategy that 90 to 95% of all plant species depend on. So when you walk through our forests or by the spit or bike in Post Canyon, most plants around you are connected to this unseen fungal network, and it's considered one of the most pervasive and successful ecological relationships on the globe. In fact, some plants are completely dependent on mycorrhizal fungi for survival, and this partnership isn't the exception, it's the rule. And you can go so much deeper here, so if this is interesting to you, there's so many different ways that mushrooms connect with plants. And the thing I find most interesting about this is we can actually use our observation usually to decide what plants are mycorrhizal. And yes, there's slimy ones that might try to trick us. But amanitas, russulas, lactarias, coral, chanterelles, boletes, truffles, all of these are big fleshy fruit bodies because they are directly plugged into that sugar. They're this big fleshy mushroom because of the sugar. So the porcinis here, the chanterelles, these are mycorrhizal. This is why they're not gardened or farmed. They need to be foraged because they need that mycorrhizal network. Decomposers tend to have much smaller fruiting bodies because they don't have access to that rich sugar. So, I feel like we've done so much. We've gone over so much. But I want to kind of bring it back home to a specific place, to the Twin Tunnels Trail. It's beloved. We cross-country ski there in the winters. Many of us have run marathons there. We bike there. I've seen roller derby host some pretty rad training sessions there. And last fall, it burned. As it reopened, I had the privilege of watching it wake up. I would run there every single week, and I didn't see any changes. It just smelled like charcoal. Until one day, I heard it before I saw it. It almost sounded like a fire crackling. The bugs were alive. There was trees in the trees. Every single tree had a bird getting at those bugs. It was so loud. And as I turned my attention from the canopy to the forest floor, I gasped because there was a carpet of purple cup fungi, those little ascomycetes, just carpeting for miles. And when I looked closer, I saw an even wider diversity of cup fungi. Some were little and orange, and some, when you crush them, smelled like sulfur and are very ceremoniously called fairy fart mushrooms. But seeing all of these cups, this is a common occurrence after a fire. There's actually an explosion of these ascomycetes after a fire because the fire affects the first few inches of the soil. So what were these guys doing? Well, even in the days to weeks after the fire ended, they binded the soil during the early forest recovery. They decomposed charred material. They sequestered carbon. They captured transient nitrogen pulses after the fire. They reduced soil erosion, and they enhanced moisture retention. In the same way that some plants can't reproduce without fire, like the ponderosa, it can't germinate without a fire. There's always also fire obligate fungi, like these morels. So I'm gonna plug iNaturalist one more time. We're not good at estimating diversity. We're not good at identifying mushrooms in the field. We are not good at biogeography or phenology, like the seasonality of mushrooms. We're not good at population trends. We don't know which mushrooms are threatened or endangered. We don't have a baseline or historical data or firsthand accounts. And the climate is changing. So now that you all have some of the basics, one important way to engage with mushrooms is to help document them. The people who are collecting data on mushrooms isn't mycologists or people in universities, it's us. And it can help inform policy that will help protect the habitats that fungi depend on. You know, we depend on fungi because they're the major players in cycling and sharing materials and the energy in the world around us. Robin Wall Kimmerer from Braiding Sweetgrass said, "Knowing that you love the earth changes you. It activates you to protect, defend, and protect and celebrate. But when you feel that the earth loves you in return, that feeling transforms the relationship from a one-way street into a sacred bond." So, I want to invite you, the next time that you encounter a mushroom, and it's calling to you, to pause and give it the gift of your attention, and perhaps document it to add to our knowledge. When the mushrooms call to you, I hope you listen. Thank you.
Okay. We still have time. You brought amazing show and tell.
Yes.
And what we're going to do is take some time for some Q&A, and then we'll release you all to come and ask Krista questions, knowing that she does have children here that have a bedtime. So this is your chance. Ask questions. Don't be shy. Be curious people. Yes, sir.
If you pick a mushroom and you crumple it up and throw it in, like under a tree and stuff like that, is that going to help that much, or because I do that all the time, and it doesn't seem to be producing much. But I was just wondering if that's an effective way to
if you move a mushroom from one place to another and you try to like inoculate a tree, is that what you're saying?
Yeah, pretty much.
Yeah, I've had a lot of morels in my yard, and I've put a lot of morels into my yard, and so I would say it doesn't hurt. But if it breaks, like there is a specific type of mushroom that I'm like, oh, I bet it's that kind of mushroom if it breaks like that. That might need a specific type of tree. It might be a specialist, or it might be a generalist. So you'd have to think about the ecological role. You'd have to know your mushroom. But that said, I've had some real weird things come up after I've thrown, spores around, so.
Up here top. Go ahead, Jeff.
So you talked about the parasitic bodies. Is there a parasitic, like the mycelium? Does it all kind of work separately or together, or does it take over itself and things?
Totally, yeah. It's all at a mycelial level because that's the body of the fungus. So actually up here, there's this little white mushroom, and it kind of looks like mold on it, but it's actually a hypomyces, like a type of mold that grows on some mushrooms. So yeah, if you see a mushroom, there has to be mycelium there, and it has to be attached to that mycelium. It's all about the mycelium, 100% all about the mycelium.
Right over here.
So is it fungi or fungi.
Oh, so
Nobody seems to agree on
boy,
this.
should we ask Mr. Bug over here?
We really should just ask Wikipedia, because Wikipedia has, I think, like, what, how many? 8? 6?
Here,
6?
Michael Bug here, wearing his mushroom hat.
Go, Michael. Let's go.
Is whatever you pronounce with enthusiasm, because we haven't got a clue how Latin is properly pronounced.
Yeah.
Michael is a local mushroom expert who I'm guessing many of you know, but he's also who helped me not be scared of them anymore, so thank you. Well, how do you pronounce it? You did a little bit of both.
I move around.
Okay.
Yeah. No, really, on Wikipedia, if you're like, how do you do it? They have, like, I've never seen a word that has so many different pronunciations. Feel free to say it how you will. With enthusiasm.
Who was up here out of question? There you want to pass it? Hi, Simone.
So can you incorporate mycelium into your gardens?
Yeah, actually there's certain types, but usually it can come from a mycelium, but usually it starts with the spores. So you can buy spores from local spots, like there's some types of, they're called like wine caps that love to eat, so they're saprotrophs that love to eat like bark chips or something like that. And they can be like big, gorgeous fruiting buddies. Well, they would help recycle those nutrients back. Yeah, generally the stuff that we can control pretty easily are saprotrophs, so they would be recycling. The mycorrhizal stuff, it's a lot trickier to help it plug it. Everything just kind of needs to be perfect. But feel free to crush your mushrooms and throw them at the base of a tree and see what will happen.
Here's Jody.
Adding to the knowledge.
Thank you so much. This is great. So I have mushrooms that are growing like crazy in my yard, and I want to know if I can eat them, and so I go through Bug's book and I look at everything the rain brings, and I've even made spore prints, and I can't get to one that says you can eat this, but I also don't get to one that says you can't. So where do I bring these mushrooms to get them identified by people who know?
Well, I have to say, there's no greater way to become better at identifying mushrooms than joining the Oregon Mycological Society. It's given me so much. And they have it's tricky because it's in Portland, but that you can just bring any mushroom there and they will identify whatever you bring. But also, I'm free at all times. I love nothing more in the spring and fall. I don't know who anyone is. I have nobody's number saved, and I just get mushroom. I'm like, yes, they're coming. Oh, you brought it, yeah. Oh, yeah, we'll put it down. 100%. 100%. 100%. Let's go. I love it. I can't see. It's not very.
It's over here now, Krista.
Oh,
Yeah,
it's being
top
passed
corner.
around.
Yep.
Good. We love that. Yeah, but really joining an Oregon Mycological Society. Also, iNaturalist, you can identify mushrooms with AI, which you should never eat a mushroom that's been identified with AI. But then Michael and Rachel and me are also on there, and we correct identifications. So it's also a human component. And so if you posted that, then we could check your identifications, and it could be research grade, which is something that for the most part you can trust, because it means enough people agree. iNaturalist.
Up top here, top left.
Hi,
Hi.
thank you so much for that enthusiastic and heart. I just felt all your passion and love.
Thank
It
you.
just is so beautiful. So in our yard, I think it's a similar question. I'm just curious, when all of a sudden you have tons of fruiting bodies, I want to know, is there a reason? Are they like, oh my God, there's nitrogen missing in the soil? Or are they like, oh, there was some bark chips? Or are they like, oh, the ponderosa just is preparing to die and they're ahead of the scale and they're like, okay,
Yes.
we're preparing.
Yes, all of those things. No, but usually mushrooms are also seasonal, right? So the real time of abundance in the forest for mushrooms is fall. So you'll find little ascomycetes in the spring, but you'll find the abundance that you see in fall is really overwhelming. So that's really when, just like an apple tree is making its fruit, right? The apple, it's the same thing with a mushroom. Like that is the fruit of the mushroom. It's moving around. It's wet, right? That's really the thing that propels most mushrooms' growth is that water. So you'll notice that like after the very first rain, they're just everywhere. But that said, there's some mushrooms that will only fruit right after a fire or if something is dying. Like I know on the East Coast, they always look for dying elms or apple trees for morels. I know that like a lot of parasitic or saprotrophs will just fruit in huge numbers at the base of trees. And that can be a bad sign or a good sign, depending on who you're rooting for.
You got one more up
That's
here.
a good question. It's all a talk. There's so much here.
Go for it.
So I was talking to my coworker about mushrooms today, and he was telling me that oyster mushrooms were like invasive in the Midwest or something.
Yeah, golden oyster mushrooms, right? Yes.
So that's a fact check, yes.
Fact check, yes.
So then,
Coworker's
should
right.
you be careful to buy spores on the internet and spread them in your yard?
I'm actually so glad you asked this because I see a lot of people are like, oh, well, they're good for soil health or good for your plants, so I'm going to put 30,000 kinds of mycelium out. But like the death cap is a weedy mushroom, right? So it's not native here. So there's a lot of weedy species of fungi. So yes, you should absolutely use caution. The thing when people are like, well, I'm just going to inoculate it with tons of mycorrhizal stuff. I'm thinking, well, care for your soil. Maybe put some mulch on it. Maybe plant some native plants, because with those native plants might have a specific fungal partner. So there's a lot of it's funny too, because it's not just like mushroom spores, it's also trees. So they can come through trees as well. Yeah, I use caution, but I do think with a lot of these saprotrophs, they're like they'll only fruit once. Once their food is gone, those bark chips, they're not really gonna go. But yeah, that's a good question. Mushrooms can be weedy.
Go for it, Matthew.
Thank you, Krista. This is awesome. I am nervous about eating morels from forestry operations. So like a lot of the cuts that we have, the places we find morels, I wonder if, and I don't know if there's science behind this, if they absorb glyphosate and the other things that some of the forestry operations are doing there.
Yeah, at a clear cut that I don't hunt at clear cuts anymore, but I used to, and I remember finding like little bits of spray. Lots of people say that's not what's gonna kill me, so I'm just gonna have them anyways. But I use a lot of caution. Some mushrooms actually like rip apart molecules, so they can both accumulate toxic metal, like heavy metals, but they can also literally rip molecules apart and make them inert. But yeah, it all depends on the mushroom and the thing. As far as like you're saying glyphosate, I don't have information on that. Do you, Michael Buke?
Yes, I do. Stay away from the clear-cut areas because most of them are sprayed now, unless it's really. And these things, I am the toxicologist for NAMA, for the North American Mycological Association. So, but also I wanted to offer.
He is that person.
If you want to
He is.
friend me and then on Facebook, and then post to some of the Pacific Northwest mushroom forums, they are a tremendous supplement to iNaturalist. And we can often get to species for you. This is what I spent half of my day today, is identifying mushrooms for people. And if I'm not out mushrooming, that's what I'm usually doing, is helping people.
And when he does that, then you can also backwards search. So you could say something like, oh, are morels fruiting on the West Coast yet? Or what time did they fruit last year? And so that's really what I'm saying. Like, we're really getting real information in time with our community science movement. Pretty cool. But
Couple
good
more
question.
questions, couple more. And then
Yeah.
we'll do this and you can talk to Krista. Okay.
Yeah, I've been super intrigued to hear about the mycelium network and how it allows trees to communicate on incredible levels that we're still trying to understand. And it's dawning on me that that mycelium network is made of dozens or hundreds of species of mushroom.
are they all connected, or are there different networks? The different trees are connected, and do they all speak the same language? How does
This
that work?
is seriously a whole talk. It's seriously an entire talk. Because like we just found out, like some mushrooms can be parasitic on other mushrooms, right? So they can do that. They can steal sugars that way. But they can also, there's like different strategies, like we say mycorrhizal, but that's an umbrella term of so many different types of relationships that different types of mushrooms have. It's so complicated, and I mean, that's like a whole book. It's a whole book. It's a whole 45-minute talk. But yeah, I mean, they're all plugged into the same types of trees, the same tree.
Okay, right over here.
Are there any mushroom? I'm right here.
Oh.
Are there any mushrooms that rely on animals to disperse their spores, or is it mostly just the wind?
Oh, that's exciting.
Oh my gosh, that's such a fun one. And if only I had a flying squirrel picture. Yeah. It's like I gotta go back to my bird picture. But yeah, the ones that underground, like truffles, and there's a really amazing one called rhizopogon, and it like bounces like a ball actually. And it's deep underground, and it's like, yeah, it totally uses animals to disperse their spores. It's such a good question. Yeah, and that's an amazing mushroom because it also helps with like forest spacing and like, it's just like a weird little ball mushroom, but man, it's the best. Maybe that mushroom is calling to you.
All right, one more.
So this is a question you may have an answer to, or others in the audience might know. I recently read that up to 20% of the population has allergies to mushrooms that are generally considered edible. And I got interested in this because my wife and I have been eating oyster mushrooms for years and gathering them and enjoying them. And just in the last couple of years, she discovered that she had gastric reactions to oysters, which she didn't used to have. And we tested that out, and sure enough, she can't eat oyster mushrooms anymore. And that's when I then started doing some research and came across information that, what I just said, that up to 20% of the population has reactions to mushrooms that are generally edible. And I'm wondering what you know about that, what you've heard.
Well, it's really about a specific mushroom. So like there's some mushrooms that are generally okay for people to eat. Like generally oysters, like 20% of the population doesn't have a bad reaction to that. But unfortunately, like I have friends that are expert identifiers that identified every morel they've ever done properly, but now they have an allergy, they get really sick to it. They didn't start out that way. Chanterelles are the same thing. People have allergies to those. If you've ever seen like the chicken of the woods, that's the one that's coming to my brain, the one that's really, it's a polypore, so it has hard pores, and it's orange on top and yellow on the bottom. Where we live, what is it, Michael, like 20% about of people can't eat it?
It varies a lot with the mushrooms, but chicken of the woods is one that a lot of people cannot eat.
Lots. So it really
I
depends.
have a number of species I can't eat, but it's very species dependent.
And in the same way that we said that, like that might feel scary, but also lots of people can't eat soy or wheat or nuts. And so it's really no different. We all have our bodies that react certain ways to foods. I'm sorry about your wife not being able to eat oyster mushrooms. It's a bummer.
Okay, because I know we have a lot of really fun show and tell, and I want to give everyone time to do that, we are going to wrap up this part and transition to this part. And the way that we do this is we have one final question for you that you get to think on while I do my little final question. Okay, come here. What is your final question that Krista, Ms. Cushman, is going to think about? Go ahead and ask her. There you go.
My final question is, if you could be any mushroom, which mushroom would you be and why?
Okay, so you think, and while you think, Alex and I are going to team up to tell you a few important announcements. One is that next month, we will be back in here talking about old growth. If you can go one more slide forward, we are going to be learning about
Gifford Pinchot the man and also Gifford Pinchot the National Forest. It's a fantastic look at basically taking this local forest as a lens into a century of how we've managed forests. And there is some hope in there. So come learn about that. I've been wanting to learn more about Gifford Pinchot the man for quite some time, so I kind of feel excited that we get to have both that and old growth and forest management. So that is next month, December 10th. Please buy your tickets early. We also, bonus, next week we'll be at the Discovery Center in the Dalles. If any of you saw Jeannie here last month and gave her a well-deserved standing ovation, she is now going to continue that story. We're going to be at the Discovery Center on November 20th. That's next Thursday, a little bit earlier. Doors at 5, show at 6. Anyone who comes to that will also get to go see the new exhibition that includes stories about, well, I guess I should tell you, since I'm assuming you all were here last month, Jeannie basically is this wild firecracker of a sheep rancher who, when the wool industry dropped out in America, she pulled up her bootstraps and has really changed the industry, including one day getting a phone call, and it was Ralph Lauren saying, we need to have American-made wool to make these U.S. Olympic uniforms, and we want yours. So that's just the tip of the iceberg. This gal is wild. And so we just needed more of her, and there's a new exhibit at the Discovery Center that tells more of that story. So November 20th, that is on our webpage if you want tickets to that. That is, the one other thing I was going to say is all tickets are up and available. Get them now. I feel so bad when people come to me after something's sold out because I want everyone to be there, and I can't control that. And I also want to say thank you all tonight for making this work with a very full, lovely volunteers, and work with CCA to make something like this work, and with a very small staff and some amazing volunteers. So thank you for sharing seats and squishing in and sitting next to strangers who maybe are now friends. I want to thank our sponsors, as always. I can't tell you how many of these organizations and businesses, literally, I send an email and they send me money. So maybe I should ask them more often for money. I want to thank Kyle, who is our photographer ninja here. If you are a Sense of Place a regular, you know Kyle sneaks around. He's amazing. You also know, well, you know that even when I have a mic, I still use a mic, so that's a tradition. We have one other tradition, which is to really give Kyle what he wants. We do a funny pose. Do you want to be part of the funny pose? Okay. We always do a funny pose that has to do with the topic. So we're going to be mushrooms of some sort. Or we could be mycelium. What do you want to be, mushrooms or mycelium? Okay, well, if I'm going to be mycelium, here, I need some other people. No, I don't want your cup. I want you. Okay, we're mycelium. We're all these, like, here, you grab their hand, too. Here, grab their hand. Okay, grab hands, everybody. We'll be mycelium. Okay, and then you are kind of the fruiting body of me when you think about it. All right. Okay. Those photos are obviously planned way in advance and very serious, so thank you for that. Okay, have I done what I need to do? Yes, except for you. And what mushroom you would be if you could be one, and why?
I'm just gonna trust myself here because there's a lot of answers I could give, but the one that keeps coming up is a tapenella. It has this like leathery top. It grows on rotting wood, and the gills are really removable because it's related to boletes. It's confusing but also amazing. And the stipe is literally velvety. Like, it has velvet on it. And it's a dye mushroom, and it makes some really amazing pigments. So I'd be a tapenella.
Okay. I mean, there we go. Help me thank Krista Cushman for joining us. Thank you to all of you, and we'll see you next week or next month. Okay. Thank you so much. Come see some mushrooms.